Hello and welcome back to the lab. Today on the bench we have another TM module. It is a SG505. These have been featured on the channel a few times before, but in a previous video where I look at the Quantasylum QA403, I noticed that my option 2 SG505 had a little bit higher distortion than my option 1 SG505. So what I ended up doing is one came available, so I picked up the unit, and we actually have a tech cal sticker on the front, so that's all fun. The cal is due in 2019, so somewhat recent, but not awful. I've been asked by some viewers of the channel if I'd be willing to work on their AA501s and AA501As. To do an alignment on an AA501, the distortion analyzer, it requires two SG505s. One is required to have option 1. The other one can be option 0. But an option 2 unit is not spec'd for doing that alignment. So because I'm getting asked to do these for other people, I wanted to do the absolute best that we possibly could, so I ended up grabbing another unit. I have not done anything with this. As you can see, this is right out of the box. The warranty void if removed stickers are still intact. We will be taking care of that little problem, and we will be voiding the warranty, not that there is one, and we will be removing those. I have not rebuilt the power supply on this, and one of the things that I want to do in this video is, because I have the QA403, I want to do a distortion measurement before and after power supply rebuild. Some of the capacitors in the power supply for an SG505 are pretty large, physically and value-wise. One of the reasons for that is to get the power supply as quiet as possible, given the space constraints of the unit. The SG505 is a pretty standard oscillator. The magic that makes this what it is in the monitoring FET and the op amps that go into making it go. So we'll take a look at that when I pull the side panel off, and we will get into it in a little bit more detail. But for those that haven't seen it or missed the video, check back in the video catalog and we'll talk more about the Quantasylum unit, but we will be putting this into service for this particular video and giving this another run. The QA403 can measure the distortion of the SG505 raw, doesn't need an attenuator, doesn't need anything else. The other thing that I really like about the QA503 is that if I set the SG505 to 1 kilohertz, I can measure not only the distortion, but I can measure the total harmonic distortion and the total harmonic distortion plus noise. The spec that I'm concerned about is the THD plus N, because that's what's actually coming out of the jack. Yeah, the total harmonic distortion could be lower, but if I have a ton of noise on the jack, I have a problem that I need to address if I'm trying to work on distortion analyzers. So that's some of the thought processes behind what's going on. What we're going to do is we're going to get this powered up. I'm going to grab the laptop, get everything all hooked up, and then we'll take a look at the distortion of this particular unit. Okay, I have the unit hooked up and some averaging done. So we have a 1 kilohertz tone coming out of the SG505 into the positive input of the Quantasylum. The negative input is terminated with a 50 ohm terminator to keep the input quiet, and I will zoom in on the results. So very respectable. We do have a little bit of higher noise than my other unit. THD is 0.00038%, and THD plus N is 0.0051, and we did 50 averages to clean this up. So it's not performing as well as my other unit. However, that could be because the capacitors are showing their age in the power supply, and the front end is having to work harder to keep this quiet. So what I'm going to do is I'm going to recap the unit, get some fresh capacitors in on the power supply, hopefully quiet that down, see if we don't improve these numbers a little bit. I am not unhappy with these as they are. These are fantastic distortion specs, but since I'm using these for calibration, I want to give them the best they can, so I'll put a couple of capacitors in it. Okay, part of everybody's favorite part. Now we've done it. Our warranty is void. Oh well. We'll just have to get some more stickers. Well, I was checking this against one of my newer older units, and these are the two capacitors that I'm really interested in replacing, along with these two as well. In my other units, these two caps right here were electrolytics and needed to be replaced. However, these are tantalum caps, and I'm going to leave them in for now. So this one's going to be pretty easy. I got to pull this board out. I'm also, while I'm in here, I'm going to service all these switches. If you run into any of these kind of switches in any tech gear, they need to be cleaned and serviced. And we'll go from there. So I'll get these caps popped out. It'll be short work with the... I'll fire up the irons and we'll try to do some on camera. Be short work with the desoldering tool, especially because I can get to both sides of the board. So nothing overly major there. So everything looks good. Be pretty straightforward. These caps right here are extremely high quality caps made by Tektronix for Tektronix gear, and those should not be changed under any circumstances unless they are proven to be faulty. I have very rarely seen any of these caps go bad, especially the tech-made timing caps. That includes all the scopes and everything like that. I've never had to change one yet, so we will see what happens. Another thing that will need to be serviced is there's a friction gear here to make turning the knob, slow that down. These will gum up with grease over time, and they will need to be serviced and lubricated. This one's running a little slowly and dragging quite a bit, so we'll be servicing that one as well. But nothing left to it but to get to it, so here we go. Okay, to get out one of these option 1 boards, it is relatively straightforward. This connector comes out, this connector comes out, and we have 4 screws that hold it in. Now the problem is we have actually 2 screws that hold it in. These other 2 are through the board. Problem is this actuator pin right here. So to get this off, we are going to pull this down. These are sometimes a pain. I will try to do this on camera and not block the view with my hands as much as I can. That one's not going to want to go. Flathead screwdriver. So these particular, there it goes. These particular controls press on to the switch. So to get this back on, you just push it in and it clicks. And that'll go. Now it's this screw, and this board will lift off. Being careful not to bash the center conductor for the sync connector. And I am using the wrong screwdriver for this. These are PZ screws. A Phillips somewhat fits. If they're not too tight, you can get it out with a P2 or a P1, but the Posidrive bits are preferred. This should just pop off now, like so. Okay, so we have a tech cam switch. We have a continuous resistor. These are there's no stops on it, so it's a continuously rotary resistor. Double gang. Let's see, what else do we have in here of interest? A lot of tantalum capacitors. Ceramic divider resistor down here that you'll want to be careful of. This light bulb is some of the stability of the oscillator. This will not light up if everything is working correctly. This is part of the feedback circuit for the op amps. So yeah, not much more on here. So we'll get these caps off, get them replaced, and then work on our intermodulation board. Alrighty, what we'll do is we will add a bit of solder to these. It looks like I beefed up the capacitance quite a bit on these bulk filters on the other unit. There's 470 microfarads in place. It looks like I put 1500s in their place, so we'll add a little bit of solder. Now we'll hit this with the desolder gun. Tilting the unit up like this and going at it sideways helps with the solder removal if you can, because the vacuum doesn't have to fight gravity pulling the solder all the way up into the back of the tool. It doesn't clog as fast, is the main reason for that. And on these, both of the orientation is the negative side of the capacitor goes to the power supply. And we have a little bit of doming out at the bottom, and we do have a little bit of crust, so might be time for a decent swap out. And that does agree with the board because we have the plus side marking on the top. (1500 microfarads by 63 volts. We'll keep this power supply nice and quiet, although I'm on my last one, so I will have to reorder. But that also explains why on my other unit it takes so long to power down. Has some really, really big capacitors in it. Okay, let those cool off. Now we'll work on these. These are 47 mic by 35. Let's see what the lab has. All right, on this board, same drill as the first. Both of our polarity marks are towards the bottom of the board with the transistors, so we will take note of that. First up, there's one cap. There's the other cap. So we'll add a bit of solder, mixing in some leaded solder to the, or some fresh solder to the old solder, makes them easier to pull off. Which is not an issue. Do this without dripping on my finger, please. Yep, getting hot. Nah, that one's stuck. There it goes. And then we're doing this in real time. Gonna be fun to try to do with a third finger. Yeah, nice and flat. These are 47 microfarads, so we did not bump the capacitance on these particular ones, but I did bump the voltage because it's what I had. So 100 volt caps fit, so these should not be stressed at all going forwards and should last a really good long time. These are also 105 degree C capacitors, whereas these blue guys are 85s. Time to get stabbed in the fingers as we pop these out. Jars are wonderful in the lab, and here's the one I'm looking for. So I have a jar of lead clippings. These can be, throwing them in a jar keeps them out of the carpet and out of a foot. If you've ever stepped on one of these that's sticking straight up, you know what I'm talking about. It hurts. And we have some nice heavier ones. But these make great jumpers when I need them. Things like that. So the other thing is doing these one at a time keeps them from eyeballs flying to Never Never Land in the back of the lab. Everybody does kind of warn, you know, hey, be careful when you use the clippers. I have had them fly off when they finally pop, especially if you're using a sharp pair of clippers. So be aware of that. As I was cleaning out this back connector, so definitely fresh Q-tip. Something that needed doing was these things needed protecting. So we'll put a little bit of contact protectant on these. This back connector, it's not going to matter, but it'll keep it from getting gross like that. That's pretty dirty. Even the gold will tarnish over time. All right, we've got our mezzanine board put back in, and we'll check the... Let's see, the key is here on this one and matches up with the key over there, so that one goes that way. Key is on that side. And there we go, so that matches up that way, which is what I would expect. Okay, to tighten up this mezzanine board, I put it back in with the Phillips screwdriver. But to tighten it back up, we are going to use the proper PZ bit. The PZ bit has these little wings in it. Come on, focus, camera. Has these little wings down the Phillips, and they're more pointed, so the bit will seat properly in the screws. Phillips bit will work, but it's a little shallow, so you risk rounding off the back side of the screw. To get the control back in, we just pop this in like so, and there we go. Everything's reassembled. That feels a lot better after a little bit of oil and lubrication. So let me get the power supply back down, turn off the soldering iron. We'll get the power supply moved back over, and we're looking for no smoke. All right, smoke test. If we did everything right, it will be uneventful. That appears to be uneventful. Well, it helps if I turn it up a bit faster. 20 hertz is a little slow. And there we go. We've got some action on the scope. So you all can see what I do. We're good to go. Let's get the Quantasylum back out and monitor some distortion for a while. Okay, we'll take a look at the spectral display. And we'll hit it. And we will ask the Quantasylum to run. And that looks better already, to be honest. We'll bump up the averages. 50 averages. And let it build this out. These seem much lower already. Our THD plus N may not be lower. We're at 0.00055%, but our total harmonic distortion did get a little lower. Let's... Oh, I should probably lock the variable. And we'll reset the averages. Okay, that's better. 0.00038 and 0.00052 is the total harmonic distortion plus N. We got about halfway to go. And this is in the floating setting, so if I ground it, it should get even better. So this is about worst case scenario. So this looks definitely some of the stuff out here is lower than it was. So let's ground the input. And we will ground reference the input, and then we'll run this again and see what happens. Now this is also worst case scenario because I have the side panels on the 505, but I don't have it in a cage. So there would be even more shielding if I had it in a power supply. And we did actually go down. Our THD plus N dropped another couple of percent, or couple of, we're really splitting hairs at this point. It's 0.00051. Oh, and our THD dropped to 0.00036. So ground referencing the input did definitely have some improvement in the signal quality. Still, way below specification for this particular unit, and I am extremely happy with the way this is performing. Everything looks good, and we're ready to service some units. So 0.00036 and 0.0051% THD plus N. So, which is total harmonic distortion plus noise. So very well done for this SG505. I'm going to let this burn in for a while just to make sure the power supply isn't going to have any trouble. And we'll see what happens. Because I'm going to let this run for pretty much the rest of the night, I'm going to throw it up on the Rigel just to keep an eye on it, make sure it's happy. And if the waveform falls out, I'll know I have something to look at. Okay, after taking a look at both of my SG505 option ones, and letting this one warm up and bed in for a while as long as the other one to do proper measurements, let the frequency stabilize. One of the things the THD and the noise looked a little high was because there was some frequency jitter because it hadn't warmed up quite yet. We are much more frequency stable, which I will show here in a second. But if we take a look, this is the repaired one. We're at a total harmonic distortion of 0.0033. But we have a THD plus N of 0.0039. Now, why is that important? So we have a little bit of harmonic distortion. Actually, it looks like the third harmonic is what's giving me kind of the trouble. And so my third harmonic's a little high. I am at negative 110 dB carrier. So that's below the THD spec of the unit of 102. Taking a look at the frequency counter, we are looking at frequency stability out to millihertz on kilohertz, so nothing horrible there. These are not hyper-precise oscillators. They're not referenced to anything clockwise like an atomic standard or anything like that. So having this jump around down here is totally fine. This being stable up here is good. Now, before it was warmed up, this was jumping around a little bit, which was causing the THD meter to go a little crazy. Now, we'll check the other oscillator. The important number to remember is 00039 for the THD plus N. So we'll hook this up to the other unit. They are both configured the same. And we will reset the averages as soon as I find the button. We'll let that build out. So as we can see on this particular unit, my third harmonic is a little bit further down. We were at it's another 2 dB. It's a negative 112. So if I look at our THD, we're at 00028. So a little bit lower. Now both of these are well under the 0.008% spec of the units. So both of them are performing well below specification. But the important thing is the THD plus N is actually pretty close. So the THD plus N would be the total harmonic distortion plus all the noise that's riding down in here. So with the total harmonic distortion being a little bit less, but the THD plus N being relatively the same, both units are in good shape and are ready to go. So thanks for stopping by and taking a look at this SG505 upgrade. Doing the capacitor update definitely did help the unit a little bit, at least from my measurements. If you have any questions, I will see everybody between videos in the comment section down below. And as always, more is always on the way. So if you'd like to support the channel, check out the links in the description to the Patreon page and PayPal. Also hit the subscribe and like button to get this on the YouTube algorithm. With that, I will see everybody in the next video. Looking forward to it.